Assalamualaikum and hi. So today we'll enter a new chapter, chapter 7, gravitation. So the first subtopic here, 7.1, gravitational force and field strength. Our learning objective here is LO 7.1a is to state and use the Newton's law of gravitation where F is equals to gmm over r square. And our learning objective 7.1b is to define and use gravitational field strength Ag is equals to gm over r square. Alright, so let us first look at the Newton's law of gravitation. So what did Newton state about gravitation? Every particles in the universe attracts every other particles with a force F that is directly proportional to the product of the masses and inversely proportional to the square distance between them, where mathematically we can write the Newton's law of gravitation such that F is directly proportional to the product of the masses, m multiplied with m, product of the masses, and inversely proportional to the square distance between the particles. So let's say if you were to have two particles here with mass m and small m here, so the forces between them here, we can explain using Newton's law of gravitation. These two for object is going to experience attractive force because according to Newton, every particle in the universe attract every other. So Newton's law of gravitation is a type of attractive force. So they are going to attract any two objects and try to bring them closer to each other, or as long as they are in contact and experiencing that attractive force. So the force that they experience here is going to become the product of these two masses. So m multiplied with m, and then you divide by the distance between these two particles, square it. Okay, so this is what we write in terms of mathematically. So the bigger the mass, your force you experience is going to become big because they are directly proportional to the product of the masses. However, the further the object gets, as your r increase here, your F is going to decrease because they are inversely proportional. This is the relationship between the force and the product of the masses and also the distance between the masses. So we have already stated the Newton's law of gravitation. Next, we're going to use the Newton's law of gravitation. To use the Newton's law of gravitation, we are going to take this proportionality and make it into an equation. Where when you make it into an equation, what happens here is your force, which was directly proportional to the mass and inversely proportional to the distance between them, is now equals to the gravitational constant. G here is the gravitational constant multiplied with the product of the masses and divided by the distance between them. So the force experienced by two particles is F is equals to gmm over r square, where F is the gravitational force. M capital and M small is the masses of the two particles. R is the distance between the particles, and G here is a gravitational constant. It is a universal constant, has a value of 6.67 times 10 to the power negative 11. So this G is a constant value. So setiap kali nampak G, quickly substitute this value. So boleh dapatkan nilai ni daripada list of constant that we have in the board there, have been attached in the list of constant. So akan ada nilai G, gravitational constant, ataupun you can also memorize. Okay, so now let's say you have two objects, particles 1 and particle 2, particle 1 with mass m1 and particle 2 with mass m2, and this is the distance between them, r, denote as r here. So object m1 is going to be attracted by the object m2, where according to Newton's law of gravitational, F on object 1 is going to equals to G m1 m2 over r squared. Okay, and then at the same time, this object is also going to experience attractive force towards the first object here. Alright, so force on object 2 is equals to G mass 2 mass 1 over r squared. So as you can see, the force of attraction experienced by the both the object towards each other are the same G m1 m2 over distance between them. Okay, so basically the force that you experience on object 1 due to object 2, 2 on 1, and also the force experienced by 2 on 1, sorry, I repeat myself, by 1 on 2, iaitu objek ini, on object 2 but due to object 1, alright, are actually the same. So dari segi magnitude, which means the value, the force of object by object 2 on object 1 is equals to the force of by object 1 on object 2. In terms of magnitude, they have the same forces because all the values in this equation are the same. So you will end up with the same value. However, their direction differ, where object 1 is going to move to the right so that dia tertarik kepada objek kedua. Objek 2 pula akan bergerak ke kiri so that dia akan tertarik ke arah objek yang pertama. So the direction of object 1 is to the right and direction of the object 2 is to the left. So their direction is opposite to each other. However, the force by 2 on 1, iaitu we are talking about object 1 ini, object 1 is going to experience force by 2. Kenapa dia experience force ini? Sebab wujudnya objek kedua berada berhampiran dengan dia. So by 2 on siapa? On 1. So we use subscript 2 1 dekat sini. Kita guna subscript 2 1. Begitu juga for the second object, you are talking about force on object 2. However, how do you experience force on object 2? It's because by object 1. Particles 2 on 1, particles 1 on 2. Tertinggal 2 dekat sini. Okay. If you find it very difficult for the subscript, awak boleh guna force 1 dan juga force 2 pun boleh diterima. Okay, force on object 1, force on object 2. However, you have to remember they are going to experience attractive force and the magnitude of the forces between the two objects is going to be the same because their value you substitute in each of the equation is the same except for the direction here. Okay, so next we are going to look at the gravitational field. Okay, what is gravitational field? Ataupun we also call this gravitational field as gravitational field strength. Okay, it is basically defined as gravitational force per unit mass of a body, ataupun mass ni kita panggil dia test mass. It is also known as test mass placed at a point. So basically gravitational field strength is defined as force per unit mass, which is force bahagi dengan mass. Okay, force divided by the mass. Okay, dalam chapter sebelum ni, dalam chapter 4 kita belajar Newton cakap force is equals to mass times acceleration. So when force divided by mass, what you get actually is the acceleration. So indirectly, this gravitational field is basically the acceleration due to gravity. Okay, dia ada kata nama lain, gravitational field is also known as gravitational acceleration. So F over m, which is your gravitational field, is basically your gravitational acceleration. So we use subscript AG. Okay, why did we use the subscript AG? Is because we are talking this acceleration is by the gravity. It's due to the gravity. So kita stick to the term AG here. AG is equals to F over m. AG is the gravitational field. F adalah gravitational force. M adalah mass ataupun kita panggil dia mass. Okay. So previously we have studied that F is equals to gravitational constant G multiplied by the product of the masses, which is m and m, divided by the distance between the two objects. Let's say you have object m and object small m here. So the force between these two objects is gmm over r square. If you were to find the gravitational field AG here, it becomes F over test mass, where your F is basically you are going to substitute whatever you have learned about gravitational force. Since this is gravitational field, maka F dekat sini kena jadi gravitational force, Fg. Tak tulis subscript kecil pun tak ada masalah. And then divided by the mass. So you cancel the test mass yang kecil ni cancel, you will end up with AG is also equals to GM over R square. It's the same derivation here. Alright, GM over R square, where the force here is the force between two objects due to that gravitational. So we talk about gravitational force, F over M, the attractive force. And then you substitute your F such as GMM over R square. And then dapatkan AG kamu sebagai GM over R square. So dia ada dua equation dekat sini. Ini by definition, ini adalah by derivation. Okay, G is the gravitational constant. 6.67 times 10 to the power negative 11. Ada dekat muka surat sebelum ni. And then mass here is the mass. R here is the distance between a point. And also the mass M here. Selalunya dekat a point ni kita ada test mass itulah. Next we're going to look at the graph of AG against R dekat sini. How does the value of your AG varies with the value of your R? Okay, so usually since we are talking about the gravitational field, you are going to relate to the earth. Okay, ini adalah bumi kamu and you have the radius of earth as capital R. So this capital R here is the radius of earth. Radius of earth is a constant. Radius of earth. Okay, selalunya dia akan bagi dalam soalan ataupun boleh tengok dalam list of constant. If given in the question, use whatever is given. Sebab nilai yang dia bagi akan varies daripada 6.38 darab 10 kuasa 6 meter to 6.4 times 10 to the power 6 meter. So nilai dia akan berubah dalam range inilah. So refer to whatever given in the question. So this is your radius of earth. Okay, to have a graph of AG versus R here, R dekat sini adalah jarak between a point and a mass M. Ini mass M kamu usually adalah earth lah. Mass M kamu dekat sini adalah usually it is a earth here. Object reference kita dekat sini sentiasa bumi. So kalau kamu tengok dalam bumi ni kita ada radius dia. So the small r in the equation here adalah daripada center of earth sampailah ke mana-mana titik yang kita nak kaji. Okay, so you want to identify what is the gravitational field strength that you're going to experience at any point daripada earth sini. Ini earth, this is your earth. So let's say this is your point here, point P here. So you want to find what is the AG at point P. What is the AG at point P? Ataupun boleh jadi you want to find what is the AG at point M sini pun boleh. Tak ada masalah. Let's say this is point M sini. Doesn't matter. So your AG is going to varies as your R berubah. R ni dengan R ni tak sama. Yang penting it has to start from the center of the earth. Okay. So as your R is going to increase, according to this equation, AG is equals to G M over R square. As your R increase here, your AG also increase. Okay, R increase, AG also increase. Okay, when you're exactly at the surface of earth, bila kita berada betul-betul pada permukaan bumi dekat sini, your AG here is equals to G. G adalah 9.81. This is constant. So now do you understand why do we have gravitational acceleration AG sebanyak G sebanyak 9.81? Because we are at this particular point. And if you substitute the gravitational constant 6.67, the mass of the earth and the radius, dekat sini titik kita adalah radius of the earth, you will get 9.81. So it's a constant here lah. And then once you get out of the radius of earth, maksudnya kita dah keluar daripada permukaan bumi ni, kita dah start berada dekat sini. So your value of Ag will slowly decrease as your R increase. Okay, dia inversely proportional. Okay, I repeat, when your R is smaller than the radius of Earth, maksudnya kita berada di dalam kawasan bumi ini, dekat tempat yang panas ini, your Ag is directly proportional to your R. So, as your radius increase, your Ag akan increase slowly. But when you are exactly at the surface of the Earth, bila kita berada pada permukaan bumi, R kita sekarang sama dengan capital R, maka your Ag is equals to G 9.81 meter per second. However, as you get out from the surface of Earth, bila kita dah mula keluar daripada surface of Earth, that is where your Ag are inversely proportional to your R square. Your Ag will become inversely proportional to R square, di mana as your R increase, your Ag akan mula decrease. As R semakin besar, Ag semakin kecil because they are inversely proportional. Okay, so this inversely proportional according to this equation is valid after kita terkeluar daripada permukaan bumi. So kita akan ada 3 situasi. Situasi pertama kita is where you are inside the Earth. When you are inside the Earth, contoh saya lukis dekat sini. Ini situasi pertama kita. This is your first case. Alright, your R is somewhere sini. Contoh ini titik yang kita nak kaji. Kita panggil dia Q. So this is your R here. So at this particular point, R dia dapatkan dalam soalan lah berapa dia bagi tahu. So your Ag here becomes Gm over R square. Okay, so M dekat sini sebab kita berada di dalam bumi, the mass here becomes the mass of the object yang dekat sini lah. Apa saja objek ataupun titik yang kita nak kaji, M dia adalah mass of that particular thing. And then R adalah jarak dari sini ke sini. This is your R here. And then you insert, you're going to get as your R increase here slowly, your Ag will slowly increase juga. And once you are at the surface of the Earth, bila kita sampai dekat permukaan sini, contoh, R kamu sekarang is basically the radius of the Earth. Okay, your R in this equation, this one now, is equals to the radius of the Earth. When you are at the radius of the Earth, the mass here become mass of the Earth. So, jadi mass of Earth. Okay, bila dia mass of Earth constant, masukkan nilai mass of Earth. Boleh tengok dekat senarai list of constant. R, radius of Earth constant juga. Gm pun constant. So as you can see, the value did not change. Ini constant, G constant, mass constant, radius of Earth pun constant, maka you will get a constant value every time bila awak berada di permukaan bumi. Tak kisahlah dekat mana lokasi kamu, as long as you are on the surface of Earth, doesn't matter at which point, but as long as you are on the surface of Earth, nilai yang kamu dapat untuk Ag adalah G 9.81. And then as you get out of the Earth, bila kita dah mula keluar daripada bumi, katakan awak berada pada titik sini. Ini titik yang kita nak kaji. So your radius, iaitu your distance sekarang, become from the center of Earth to wherever your object is. Okay, so this is your R now. So your R here now, R dekat sini adalah basically, awak ambil radius of Earth kamu, bahagian sini, radius of Earth, campur dengan whatever distance you are from the surface of Earth. Ini permukaan bumi. So apa saja jarak kamu daripada permukaan bumi itu. Apa saja jarak kamu daripada permukaan bumi itu. Ini kita panggil H, height. Any altitude from the surface of the Earth. So your small r now becomes the radius of Earth plus dengan H dekat sini. So kita ada 3 case. Okay. Depends on how your R varies. Your R here, R kecil ni dalam muka bumi. Dalam muka bumi, pada permukaan muka bumi ataupun di luar permukaan bumi. Inside the Earth, on the surface of the Earth ataupun outside the Earth. Kita ada 3 case dekat sini.